But you can't actually do any of this data science, the stats, or the ML without the right tools, right?
Correct. The tools of the trade are essential.
So let's talk programming languages and specific tools. Being able to write code seems absolutely critical.
It really is. Programming skills are essential for everything from cleaning and manipulating the raw data to building and training those machine learning models, creating visualizations to understand the results, and actually deploying these solutions so they can be used.
And are there specific languages that are dominant?
Yes, definitely. Python and R have really emerged as the two major players in the data science world.
Okay, Python and R. Why those two?
Well, Python has become incredibly popular. It's very versatile, relatively easy to learn, and it has this amazing ecosystem of libraries specifically built for data science.
Libraries, like pre-written code module.
Exactly. Things like NumPy for efficient numerical calculations, Pandas, which is fantastic for organizing and manipulating data. Think of it like a superpowered spreadsheet you control with code.
Ah, Pandas, I've heard of that one.
And scikit-learn, which provides a huge range of standard machine learning algorithms ready to use. Python's a real workhorse.
Okay.
R has its roots very firmly in statistics. It was developed by statisticians for statisticians, so it's incredibly powerful for complex statistical analysis and especially for creating really high-quality, insightful data visualizations, charts, and graphs.
So Python, more general purpose, are maybe more specialized for stats and viz.
That's a common view, though both can do a lot. Python's versatility and large community give it maybe a slight edge in general ML deployment, while R remains a favorite in academia and for specific statistical tasks. And we can't forget SQL.
SQL, structured query language for databases.
Precisely. Most data still lives in databases, so knowing SQL is fundamental for actually retrieving the data you need to analyze in the first place. You need to be able to ask the database for the right information.
Got it. So Python, R, SQL, essential languages. What about visualizing the data, making it understandable?
Crucial step. Data visualization tools are key. You have dedicated software like Tableau and Power BI, which allow you to create interactive dashboards and reports, often with a drag and drop interface.
Right, for business users maybe?
Often, yes. But data scientists use them too. And then within Python and R, you have powerful visualization libraries. Python has Matplotlib, Seaborn Plotly, R has ggplot2, and others.
And what do these do?
They let you take all those complex numbers and findings and turn them into visual representations, charts, graphs, heat maps, scatter plots. This is often the best way to reveal hidden patterns, trends, and outliers, and crucially, to communicate those findings effectively to others, people who might not be data experts.
Makes sense. A good chart can tell a story much better than a table of numbers.
Absolutely. Oh, and one more tool worth mentioning, especially when dealing with really massive data sets, we're talking terabytes or petabytes, is Apache Spark.
Spark? What's that for?
It's a framework for distributed computing. It allows you to process huge amounts of data much faster by spreading the work across many computers, like a cluster, all working together, essential for big data tasks.
Okay, so a whole toolkit of languages and software.
Looking at the bigger picture, yes. Proficiency with these tools is what enables data scientists to actually perform the analysis, build the models, and, very importantly, communicate their findings in a clear and compelling way.
Okay, we've hit the stats, the machine learning, the coding tools, but there's one more really important piece we mentioned earlier, domain knowledge.
Ah, yes, the context. This is so important.
Explain that. What is domain knowledge in this context?
It's basically having a specialized understanding of the specific field or industry where you're applying data science. So if you're working in healthcare, it's understanding medicine, biology, hospital workflows. If you're in finance, it's knowing about markets, regulations, financial instruments.
And why is that so critical? Can't you just be good at the math and the coding?
You could be the best coder, the best statistician in the world. But if you don't understand the context of the problem you're trying to solve, your work might be technically brilliant, but ultimately useless or even harmful.
How so?
Well, domain knowledge is crucial at every single stage. It helps you identify the right business problems to tackle in the first place. It helps you ask the right questions of the data. It guides you in selecting the relevant data features to focus on, choosing the most appropriate analytical techniques, and critically interpreting the results correctly.
So it stops you from building a model that works technically, but doesn't actually address the real-world need.
Exactly. Or a model that produces results that seem statistically significant but are actually meaningless or misleading in the real-world context because you didn't understand the underlying factors at play.
Give me an example, maybe.
Okay, imagine building a model to predict customer churn, customers leaving a service. A purely technical approach might find some correlations, maybe people who click a certain button churn more. But someone with domain knowledge of the product and customer behavior might know that why they click that button is the real issue. Maybe it's a sign of frustration with a confusing feature. The domain expert can guide the analysis towards more meaningful factors and help interpret the why behind the numbers.
Got it. So it provides the meaning behind the metrics.
Precisely. And this is where the data scientist often acts as a bridge or maybe a translator. Yeah, translating the complex business problems into technical questions that data science can answer, and then translating the complex technical results back into actionable insights that business leaders can understand and use. This requires really strong communication skills too.
So it's not just about being good with computers and math. You need to understand the business and be able to talk to people.
Absolutely. That blend of technical depth, domain expertise, and communication ability is really the ideal for a data scientist.
Zooming out then, the ability to connect the technical analysis with practical real-world understanding is what ensures data science actually delivers tangible, valuable outcomes, not just interesting R&D projects.
Couldn't agree more. That connection is vital.
All right, foundation laid. What aspects would you like us to explore further in a future session? Let us know.
We'd love to hear what areas you find most intriguing or want to understand better.